exercise set 4.3, question number 32 here. The cosecant theta of 1.002. In the class, I said you don't have to remember or mess with the cosecant, secant, and the cotangent function, right? Because they're the reciprocals of sine, cosine, and tangent, respectively. But in this question, the cosecant function is given. So how do we solve this problem? Well, let's write that down over here. CSC stands for cosecant function, okay, of theta. Theta is the angle, and we're supposed to find that in degrees. According to this problem, round off the result according to table 4.1. That's what the problem says. Here's the table 4.1. I just copied down here, right? When the significant digit of the trig function has 4 significant digits, you have to find the angle down to 0.01 degrees. Okay. Looking at our trig function, the cosecant function, let's count the number of significant digits for this decimal. 1.002. Yes, significant digits can be counted by just counting the number of numbers in a decimal, right, including the integer parts. Okay, so in this case, starting with 1, skip, this is in the tens place, hundreds place, and thousands place. So there are a total of 4 numbers, right, between 1 and 2. Yeah, these 2 zeros are significant digits, even though they're, zeros, right, because they're, sandwiched by non-zero digits, which are 1 and 2. So they do have meaning, right? So this cosecant function has a significant digits of 4 significant digits, right? Which means that you have to find the theta down to 0.01, right? On the order of 0.01 degrees. But how do we do that? Well, cosecant function is the same thing as 1 over sine theta. Right? That's the definition of the cosecant function. Sec function is 1 over cos, right? Cotangent, cot function is 1 over tan function. Yeah. So you just remember those 3 fundamental trig functions, and you take the reciprocal of that, and that is being 1.002. Now this problem, it's becoming the problem, it's about the sine function instead of the cosecant function, because we have, converted from cosecant to sine. Okay, and you can easily find that sine theta is, you can just flip it over, on both sides, 1 over 1.002. Yeah. Then, well, you could, at this point, take the calculator and compute the 1 divided by 1.002. But you will get some, repeating decimals or even, irrational numbers. The better way to calculate theta for this situation is to just keep this fraction as is and then invert this sine function to find theta. Do you remember? There's an invert function for sine theta, a sine function called the arcsine, right? Arcsine function. Arcsine function is written either, sine to the negative 1. Okay. Or just arcsine. They're the same meaning. They are the same function. What these functions take in is the value of the trigonometric function, not the angle, right? So this thing becomes the input for the inverse trig function, like sine, arcsine, arccosine, arctangent, right? So this is what you need to enter in your calculator, right? Or if you find arcsine button, yeah, you want to push that button, and then your input for these function will be 1 over 1.002, and when you hit the enter, you should get 86.379311259, and there's more decimals to follow, but you have to truncate this in a infinitely long decimal somewhere, right? And so that's when we use this table 4.1. You have to truncate, round off to the nearest hundredth degrees, right? Hundredths place. So here, to round to the hundredths place, you want to look at the number in the thousands place. And if that number is greater than or equal to 5, you round up the number. So you increase the number in the hundreds place by 1. If the number in the thousands place is less than 5, namely 1, 2, 3, 4, 1 through 4, then you round down. So you truncate all the rest of the decimals without changing the number in the hundreds place. In this case, you're rounding up because the number inside, in the thousands place is 9. 9 is very close to 0, it's 0. So you round it up and you bring 7 up to 8. So the answer is 86.338 degrees. Okay, so that's how you find the answer. Okay, so that's it. Thank you.